As we discussed before, design is different from analysis in that analysis was the discovery process. Uh, Design was the invention process. The design models the code. The analysis sort of models the requirements at a very high level. It says what the analysis identifies what is inside the system. The design models how it's going to be implemented in the code. So in object-oriented design, you can think of using the same modeling notation, the same UML notation. It's just more detailed. So, for example, how the relationships between the objects are maintained, the associations, for example, between the objects. In the analysis, we simply draw a line between the classes on the class diagram to say, hey, an object instance of this class may be linked to an object instance of this other class. And we identify the multiplicities, but we in fact don't even get into discussions or worrying about where that information about the linkage is stored. The relationship between two objects may be stored in one object or the other object, or in fact someplace else, or some combination of those. And that's really a design decision about where the references are stored. Okay? So you have to identify and design which objects contain the stored pointers to which other objects. And the dynamic models are in a much more lower level of detail. We're getting almost down to programming level of detail in some of the dynamic models. We have to identify which objects send messages and which messages to which other objects in what order. And so we're actually getting down to levels of detail that some people might think of as programming. I would prefer to think of it as design, and I think that when a lot of programmers make those decisions, they're not really making programming decisions, they're making design decisions. So I would rather have my designers make programming decisions, what normally programmers would think of as programming decisions, but in fact they're design decisions, rather than staying at too high a level for my design and then let the coders make too many decisions about actually, what they would be making decisions about are design level kinds of things. So we need to keep in mind that we're designing how the objects are going to work, how we represent the information in those objects, and how we represent the connections between the objects, and how we represent the behaviors of the objects. At design time, we may need to introduce some additional classes of objects. Remember, one of the things that we mentioned when we were talking about analysis was that you do not specifically do not get into details of implementation objects, such as collection classes or maybe a lot of the UI kinds of things that are not needed, that you don't even need to know about from the problem domain point of view. Okay? So now in design, since we're modeling the way the code works, we will introduce those lower level classes like collection classes and UI classes and things of that nature. We're going to use the same notation. It's just we used a subset of the UML notation in our analysis models. Now, for our design models, we use the full UML notation. So if, for example, if I have an association between two classes at analysis time, it's just a line. At design time, I indicate where that association is actually stored by using a directional arrow instead of just a line between the two objects to indicate which object contains the reference to which other object. The sequence diagram includes detail of the sequence of the operations. You can add the detail of the signatures of the parameters being passed. You can also indicate if I need to send a message from object A to object B, but in my class diagram, A does not contain a reference to B. It's not a static relationship. Somehow, dynamically, at the point in time when that object needs to send the message, it has to have acquired the reference to object B. Well, in our sequence diagram, we should be showing the level of detail of how the object receives or somehow obtains the reference to that other object that it needs to send the message to. And so that will be an extra few messages and parameters being passed around and things, that level of detail that we did not show at analysis time. And lots of other concerns that really we sort of, I wouldn't say ignored, but that wasn't really germane to the analysis modeling, but they are very definitely part of the design modeling, are things such as performance. We have to worry about performance optimization. We have to map to the technical architecture. We have to worry about persistence. Persistence of objects means that the objects, as you know, run in memory, right? And if the memory is turned off, the data of those objects goes away. Now, if you want to guard against that loss of data, then you're going to need to persist the objects. You need to store the data for those objects in something more permanent, such as a database. And the right frequency with which you do that is every time the data in an object changes, you may need to send new data off to a database. You have to worry about things like security and interface to legacy systems, existing systems that you don't really want to throw away, but you want to provide a new object-oriented interface to those legacy systems. And the specific mechanism for communication from one process to another. So those are just some of the additional things we have to think about in design that we didn't really need to worry about at analysis time.